Hey everyone, welcome to today's video. For today's video, we're going to focus on talking about synthesis chemical reactions, specifically what they are, and how to predict products from a chemical reaction that is a synthesis chemical reaction. Let's go ahead and get started. A synthesis chemical reaction is just a chemical reaction where two substances are combined to form one product. So if we had one substance A that was going to undergo a chemical reaction with another substance B. Maybe these are two different molecules, maybe they are just two different elements. When they undergo that chemical reaction, they will combine to form one compound, molecule, one substance made up of both element or molecule A and element or molecule B. Let's go ahead. It's that simple. Let's go ahead and take a look at a couple examples and how to predict chemical reactions that follow this kind of format. Okay, to predict the products of a synthesis chemical reaction, you just follow three quick steps. Number one, write out the substances participating in the reaction. So if you're reading this or if you are just trying to figure out if you have the substance available, just write them out in the form of a chemical equation that you're about to start. Second step, write the valence charges underneath those elements that are participating. And then combine the two and write the balanced chemical formula for those two elements combining in the reaction. Let's go ahead and demonstrate that. Okay, the first example that we'll take a look at is oxygen and hydrogen reacting. So the first thing we'll do is we'll write out the symbols for these two, how they would exist. Hydrogen and oxygen, they are part of a group of what's called diatomic elements, which is they don't exist in nature by themselves. They are always going to be bonded to something. And diatomic just means there's always going to be two of these together. The acronym is called, I'll write it over here, Hofbrinkel. That is hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These are always going to be in a diatomic molecule that is having a 2 after it when you write it down, at least here on Earth in most cases. Obviously, there's always going to be exceptions. So let's go ahead and get that looking. Oxygen here has a -2 charge. Hydrogen has a +1 charge when they become an ion. How these are going to combine together, we need both sides to kind of even out. So there's 2 here, there's 1 here, we need to add 1 more. So when we write that over here, we'll write the positive first. It's always going to be the positive that gets written first. H, and we have 1, 2. And then we have O. And there's only 1, so we'll just leave that blank. So when you combine oxygen and hydrogen, you end up making H2O. Well, that's just water. Let's go ahead and take a look at a few more examples. Okay, another example. We have sodium and we have chlorine. Let me rewrite. That down there. Okay, so first step, write the symbols down. Sodium symbol is Na for natrium. We add that plus sign in our chemical reaction to show that this plus this is going to get us something. Cl, and is this part of Hofbrinkel right there? So we got to add a 2 right there. Sodium is not a part of this, so we're good. Arrow just shows that there's a chemical reaction happening. These two are going to react together over here, so we have a -1 charge for chlorine, and we have a +1 charge for sodium. I have a list that tells me what these charges are. I also have a periodic table that has it listed up at the top. If you are unsure how to find these charges, where all this works, there should be another video up here in the corner for you to check. I apologize if there's not. We write the positive ion first over here when we rewrite these chemical formulas of them combining. So we'll start off with sodium, and that's +1, that's a -1. They are equal, so we just write Cl right there. Now, there are 2 chlorines over here and only 1 chlorine over here. There will be a video up here in this corner, if not immediately released, then at some point. You can look at how we fix that. Is what we do is we balance the chemical equation, and then there's a separate video on that up in this corner sometime here in the next little few seconds to show you how to balance chemical equations. Right now we're just predicting the products. What molecule over here is going to be made with the substances over here. Let's go ahead and do, we'll do a couple more examples. Okay, let's take a look at what a chemical reaction between barium and bromine would make. It's going to have those two in it. So we will write barium. That symbol for barium is Ba. That is not one of our Hofbrinkel, so we will just keep going. Put a plus sign there. Bromine, Br is the symbol for bromine, and that is one of our Hofbrinkel, so we'll write the 2 there. Barium has a charge of +2. Bromine has a charge of -1 in that halogen side there on the periodic table. We are lacking some bromine, so we'll add a -1. And we'll go to, well, that's just it. So we write the positive one first. That is Ba, and then we have 1, 2 bromine. So Br, and then 2 to show that there's 2 bromine that combined to bond with 1 barium. If you are unsure how this process works or why we are undergoing this process, this is how these two form together in a chemical reaction. And how to make this chemical formula is by taking the valence charge, writing it out beneath, and making them balance on each side so that we have a net charge of 0. There is a video up here in the corner that will show you how to do that. I recommend clicking on that if you are unsure of this skill here in chemistry, how to tell how much bromine it takes to bond with a particular barium atom. Let's go ahead and take a look at just one more example. Okay, last example, potassium and oxygen. Oxygen's in our air. A lot of things interact with oxygen. Potassium, first step, we write the symbol down. So potassium's symbol is K. If you know why potassium symbol is K, what the Latin symbol is, please write it down in the comments. I am genuinely curious and I don't want to look it up. Oxygen, its symbol is O. And take a look at K, not part of our Hofbrinkel, so we leave it as is. Oxygen, right there, so we got to write it as 2. We've also used it before, so we could also just remember that. Okay, we got to write the valence charges underneath. Potassium is in group 1, it has that +1 charge. Oxygen has a -2 charge, so we are going to need 1 more potassium. So we write that over here. It's going to go K, so we write that first, and there is 2 of them, so we'll put a 2 there. And then oxygen, we only have 1 here, so we just write O. That means it takes 1 oxygen atom to react with 1 potassium atom. And remember, we only have 1 oxygen, and we have 2 potassiums over here, but there's 2 oxygens and only 1 potassium over here. We fix that later by balancing the chemical equations, and we'll show how to do that in another video. That's all I have for today, folks. I hope this was helpful in helping you predicting products with synthesis chemical reactions. We will do another one on how to do other forms of chemical reactions, such as decomposition chemical reactions. You can watch that video up here in the corner here. If you found this helpful, please like and subscribe. And I will see you guys all in the next one. Take care.